Hi everyone, thanks for tuning in to this week's Synapse video series. I'm Mark Hamilton, a software engineer on the Synapse Analytics team, and today I'm very excited to share with you a tour and a welcoming to our open source distributed machine learning library, SynapseML. So we'll first answer the question that's on a lot of your minds. What in tarnation is SynapseML? Well, SynapseML is an open source and distributed machine learning library that is specifically designed to be simple and easy to use. We try to take a lot of different machine learning pieces and components and make them composable like little Lego building blocks so that you can build really big and rich structured applications with a very small amount of code and a very small amount of legwork on your end. It's scalable. It's really designed to execute either on your laptop or on hundreds of machines in elastically scalable and resizable Apache Spark clusters. And most importantly, it's open. All of it's open source. It runs on multiple different platforms, Synapse, Databricks, HD Insight, really wherever you get your giant Spark clusters, or even on your local laptop, we want to be able to run SynapseML there. In more technical detail, SynapseML is a distributed machine learning library that builds on top of the SparkML library. It adds all sorts of new capabilities for reinforcement learning, deep learning, cognitive service orchestration, and large-scale language modeling. And to do this, it embeds a lot of different products and services from across the Microsoft ecosystem and the broader ecosystem in general, so that you can use all different kinds of tools within your Apache Spark cluster, all within a nice, simple interface. SynapseML's unifying API is available in a variety of different languages that Spark supports, be it PySpark, which is the Python language bindings, Sparkly R in the R ecosystem, Java and Scala, which Spark Core is written in, and as of our latest v0.10 release, we included support for .NET, C#, F#, and that whole family of languages. And a big shout out here to Serena, who made this integration possible. So, now that we've got a 1,000-foot overview of what SynapseML is, let's see it in action. So today I'm going to show you a quick 5-minute demo that's going to give a basic overview of the SynapseML API and its basic functionality. To begin, we'll load up a data set here of book reviews on Amazon, and we'll split it into a training and testing set. This data frame has two columns, one for the rating that the customer gave the book, and the other for the text that the customer wrote about this book. These are kind of paragraphs of text that you'd see in a product review. Some are fun, some are snarky, some are downright mean, some are really nice. And our goal today is going to be to predict this rating column from the text itself, a classic text regression problem. Lucky for us, SynapseML makes this process fairly simple. Once we've loaded our data set and split it into a training and testing set, we can move on to creating our model. Today, we're going to use a fairly simple model that consists of a SynapseML text featurizer and a LightGBM regressor. The text featurizer is going to take all of that text we have in our text column and split it out into tokens, and then map those tokens into sparse vectors for machine learning algorithms to work with and learn with. So for those that might not be familiar with LightGBM, it's Microsoft's own gradient boosted tree framework. And what this does is it builds a large, complex, and rich model out of many small trees layered together that try to learn rules for predicting the output from the input. This algorithm is on the back end of a variety of different Microsoft services like Bing and the search on your computer, and so you've definitely interacted with it, whether or not you know it. And before I get any crazy comments about Bing, it's probably something similar in Google too, because these things are very efficient and very performant, even though they are trees and not deep networks. Surprisingly, in many cases, they're often better than deep networks. So that's what we're going to use today. It's fast, it's simple, it's very performant. And so I'll briefly note here that we've used this SparkML pipeline here to unify the two stages into a larger model. Here I'm combining the featurization and model fitting into a single step, and I'm fitting it on my training data set. Now with my fit model, I can move ahead to predictions, and here I just transform my testing set and visualize the results here. And you can see that I've added in a column to my data frame called prediction, and it has all of our predictions from our model. So here in this view, we can see how each individual piece of text maps to a prediction that LightGBM spit out. But we can also get a more aggregate view by using Synapse inline charting utilities and see how our average prediction maps onto the actual rating given by the user. We can see that there's a fairly nice linear relationship here. And these are average predictions, so each one of these is going to be a large distribution, but here we've just shown the average for simplicity. So I know what you might be thinking. At 15 lines seems like a lot of legwork. So we have the solution for you, lazy developers. And so now what we're going to do is we're going to do this problem again, but instead let the cognitive services do all of the legwork. The cognitive services are intelligent pre-built algorithms that are hosted and maintained by Microsoft and designed to solve a wide variety of general purpose AI tasks without any training, without any GPUs, without any pain. And they're also designed to be state-of-the-art so that you can apply these and get very good results. So here, just like creating a light GBM, I've created a text sentiment transformer, and I'm going to transform my testing data set. Just as the light GBM model added predictions, this is going to add a sentiment column, and you'll see that the sentiment columns are positive and negative and mixed, and this bore of a story here gets negative, and things that are a little bit more nuanced get mixed and undefined results. So with that, we've seen how we can very quickly solve this rating prediction problem with two different styles, one by training your own with LightGBM, and another by using a text analytics. You can now present both of these solutions that we've created in 5 minutes to your persnickety boss or customer and let them decide what's best. And better yet, this isn't only possible on Synapse Analytics. It's possible to do this exact demo on Databricks. And you can even do this live in browser by going to our GitHub repository here and clicking on the Launch in Binder tab. This is going to boot up some of these demos live in browser so that you can play around with it at home without having to boot up any sort of cluster. And so with that, thank you very much for listening. Make sure to like, follow, and subscribe to this YouTube channel for more content like this. And definitely reach out, give us a star on GitHub, keep us employed, and thank you very much for your attention. Have a great rest of your day.